Okay, here is part 2 of my workshop on using Python to solve physics problems. And so in the previous part, I went over how to model the motion of an object moving at constant speed, how to model the motion of an object moving with a constant acceleration. And we did this print stuff. So you printed out all the values and stuff like that. It's cool and it works. But how do we make a graph in Python? So I'm going to show you some very basic stuff. I'm just going to start off, and this is a blank program, and then I'm going to modify the program to make it work. All the code is still online at trinket.io. I'll include a link down below. So the first thing I'm going to do is make a graph. Okay, so I'm going to say F1 equals G curve. And you got to spell it right. So F1 is just a name I pick. I call it like for function 1. I don't know why I always do that, and I can't stop. You could call it whatever you want. And G-curve is a built-in function in GlowScript. So if you ever go into Trinket and you want to start from the beginning and you go over here and you go New Trinket, you want to do GlowScript. Okay. If you do Python 3, it's locked because you have to have a paid account to save. If you do this Python, it doesn't have built-in graphing. GlowScript is Python with built-in graphing. Okay, so let's just do this. If I run this, oh, go away. If I run this, nothing really happens. So, okay. But I can add a data point to my graph. So let's plot a data point manually. If I go f1.plot, and then I give the x and the y value on the graph, let's just give it a number 1, 2. Now I run it. And you don't see anything because it's right down here. Actually, let me make another graph. Another point, f1.plot. I'm going to add another point, 1.53. I'm just making up stuff there. Boom, I got a graph, see? So there's my 2 data points, one's right there and one's right there, and it connected them with a line. I can add as many data points as I want. I could just go f1.plot, let's say 2.1, 3.8. Now we're getting somewhere. Look at that. Isn't that cool? Okay. So let me add one more thing because I want to make this a little bit cooler. First of all, I can change the color of this line. This function G-curve is built in to Python. I can change this to, I can add in here color equals color.red, and I run it, and now it's a red line. Isn't that cool? You can change the parameters, you can change the thickness, all that stuff. Also, I could even do this. There's another function called G-dots, and it doesn't connect them between a line between them. It just draws dots. So there's my dots as my points. Okay, but I want G-curve. Okay, one more thing. I can actually add, if this was a physics lab and you turn this in, someone would say, well, there's no label on the x and the y axis. Who knows what they are? So let's say I'm plotting velocity versus time, and those are all velocity values. So if I go up here and say graph, x title, graph is a built-in function into GlowScript. X title equals time in seconds, and this is just words. I can write whatever I want. And y title equals velocity in meters per second. Now I run it. Watch what happens. Check that out. I can even put a title at the top. The order doesn't matter here. I can say title equals my awesome graph. Okay, wait. Did I get that right? Yep. Okay, are you guys happy? Okay, let's use these ideas with this. So this is my code before. I'm just going to copy that. I'm going to paste it over here, and I'm going to leave that like that. I'm going to run this. Okay, so it didn't plot anything because I never told it to. All I did was print out the car's position and time and all these values, which is kind of tedious. Okay, so let's change this into a graph. I already have my function. I want to just get rid of this. Let's just comment that out. I don't have to delete it, right? If I comment it out, it doesn't do anything. Now instead, I'm going to, instead of printing that line, I'm going to plot that data point. I want time on the horizontal axis and x on the vertical axis. So I'm going to say f1.plot. My horizontal value is going to be t. My vertical value is going to be x. Now let's run this thing. Oh, and I should change this because I lied. Meters. I don't want to lie, right? Position. You can call it X, whatever you want. Check that out. You like that? And so I can even get values from here, okay, by moving my cursor over like that. You could take a picture of this. I guess I should show you how to actually save a picture too. I'll show you this one thing. So if you do this graph line and then I go up here and add on there fast equals false, it uses a different function for plotting. And you can see it looks a little bit different, but you also have these controls up here. Also, you can move the axes. I can actually change this, right? I can zoom in and stuff like that. I can take a picture. I can edit it and Plotly. There's a whole bunch of other things you can do. I just want you to know that it is there. And fast equals false because technically this takes longer to plot. If you get rid of that, it goes back to the old way. Okay, so that's graphing. And then if I wanted to graph something else, I could graph whatever I wanted to. I could graph velocity versus time, time versus position versus velocity, whatever. Okay, it doesn't really matter. F1.plot puts a data point on that graph. And you can make another curve. Let's say F2 equals G curve, color equals color.blue. And then it doesn't really make sense, but I'm going to plot, let's say F2.plot T and 2 times X, just for fun. There, now I have 2 lines. Okay, but that's stupid because that doesn't even make any sense. Okay, now let's go over and back to the trinket stuff. Here is a real physics problem. Okay, this is what you would see in a real physics course. And we're going to solve this using a graph. That's going to be great. So car A starts at x equals 0.5 meters with a velocity of 0.45 meters per second. Car B starts at x equals 0 with a velocity of 0 meters per second. But car B is accelerating at 0.2 meters per second squared. When do they catch up and when do they meet? Okay. So I give you the starter program right here. I guess I can switch over to it right here. Let's see, 2 moving cars. And I'll just point out a couple of important, it doesn't run. Okay, this program does not run. Or you can run it, it just doesn't work. See, it gave me an error because I left some stuff blank. I didn't finish the graph. I didn't finish the program for you. It's an incomplete program. But a couple of important points. Number one, I have 2 things I'm graphing, the position of car A and car B. Now I have car A and I have car B. So I need 2 variables for X. I need an XA and an XB. And case does matter. So you need to do that. If you want to change the name, you can, but I call it X capital A. I need 2 velocities, right? Those are the 2 velocities. I only need 1 acceleration because the other car has 0 acceleration. I only need 1 time. So down here, if you look, I tell you what to do. You need to update the velocity for car B. You need to update the positions for car A and B, and then you can plot it. And that's not too hard to work, but it doesn't tell you the answer. There's something else you're going to need to do to get it to work. Once you get the program running, it's not going to tell you the answer. Okay, because there's something else you need to do. But I will leave that there, let you work on it. That's the second part. If you get bored and you're like, hey, I need more physics stuff, check this. Oops, that's not it. Check out all the other stuff that I put on there for you. What the heck happened? Okay. Check out all the other stuff I put on there for you so that you can calculate a whole bunch of other activities. But I'll stop right there. You don't have to do the rest for my lab, but if you want to do them on your own, that's cool too. I'll talk to you guys later.